In this lecture, we are going to see the design of muff or sleeve coupling. Okay. So the design of muff coupling has three parts. One is the design of shaft, and the second one is design of hub, and the third one is the design of key. So you can see the drawing. The shaft is inserted in a hollow circular shaft, so that is called as the hub. And the key is used to resist the relative motion between the hub and the shaft. Okay, so actually this bolt is just for alignment purpose. Okay, so this bolt will not carry any load, so we don't need to design this bolt. So we have to design the shaft, hub and key alone. Okay. So previously in the rigid coupling we have designed everything. So in that you just neglect the design of hub, design of flange and the design of bolt. You will get the design procedure for design of muff coupling. So the material is same for keys and the shaft. We can assume the material of mild steel with the sigma 1 of 90 Newton per mm square and tau 1 of 40 Newton per mm square. Then the hub, for hub let us consider the material as cast iron and the tau 2 is equal to 15 Newton per mm square. So the first step is calculation of shaft diameter. So the procedure is same. So first calculate the mt, that is torque, from the given power and the speed. Then substitute the value of torque in the shear stress equation. Substitute the shear stress equation and calculate the diameter. So after calculating the diameter by using R20 series, you can standardize the diameter value. Then the second point is dimensions of coupling. So the diameter of the hub D, so here the diameter of the hub I have considered as capital D. Capital D is equal to 2.5 times the smaller diameter, that is the diameter of the shaft. Then the length of the hub L, capital L, is equal to 3.5 times the diameter. The length of the key is half of the length of the hub, because you can see that here we have used two keys. Okay, so the length of the key is divided by 2 the length of the hub. Then here in the muff coupling we are going to use the sunk key of square type, that is square sunk key. So previously in the rigid flange coupling and the flexible flange coupling we have used parallel sunk keys, but here we are going to use the square sunk keys. So the width of the sunk key is same as the thickness and it is equal to d by 4, that is diameter divided by 4. The third step is checking the strength of the coupling. So here there is no flange, so we have to consider the hub as a hollow shaft. So the same equation, mt is equal to pi by 16 tau 2. Outer diameter is capital D and smaller diameter is inner diameter divided by D. So if the calculated tau 2 value is less than the allowable tau 2, then the design is safe. Okay, so there is no flange design, so directly we can move into the design of key. Okay, so here the key is subjected to both shear and crushing strength. So first consider the shear, use the same equation and calculate the value of tau 1. So if the calculated tau 1 is less than the allowable tau 1, then the design is safe. Then second one, by considering the crushing, again the same equation. So this fourth step is common for both rigid coupling, flexible coupling, muff coupling and the clamp coupling. Okay, so if the calculated sigma 1 value is less than the allowable sigma 1, then the design is safe. So that's all. So we have designed the shaft, hub and the key. So there is no bolt, there is no flange, so we don't need to design the bolt. So the last part is resulting dimensions. So draw the drawing and write all the calculated dimensions value. Okay, so here we have to design only the shaft, then the dimensions of the coupling, then hub, then the key. So that's all. There are find fifth point is the dimensions. Okay, so the design of muff coupling is very easy comparing with the rigid and flexible flange coupling. That is why I have started with the flexible coupling, then moved into the muff coupling. Okay, so you have to neglect some part of the flange coupling procedure so that you will get the procedure for muff coupling. So the problem is design a muff coupling to transmit a power of 35 kilowatt from a shaft running at 120 rpm. So the power is given P is equal to 35 kilowatt, that is 35 into 10 power 3 watt, and the speed N is equal to 120 rpm. Assume suitable material and stresses. Okay, so here in the problem the material properties are not given. So what I am going to do is I am going to assume the keys and shaft is made of mild steel with the sigma 1 of 90 Newton per mm square and tau 1 value of 40 Newton per mm square, and the hub is made of cast iron with the tau 2 value of 15 Newton per mm square. So these are all the assumptions. Okay, we'll move into the design procedure. So the first step is calculation of shaft diameter. We know that mt is equal to 60p divided by 2 pi n. P is given, you can see that it is 35 into 10 power 3. N is given, you can substitute that, you will get mt in Newton meter, convert it into Newton mm. So into 10 power 3. Further, after calculating the mt value, substitute it in the shear stress equation. The shear stress is assumed as 40, it is not 50, it is 40 Newton per mm square, so that you will get the diameter value of 65.7 mm. Okay, so then you can standardize the diameter value using R20 series. The next standard diameter is 71 mm. The second step is dimensions of the coupling. Capital D is equal to 2.5 times the diameter, that is 177.5 mm. Then length of the hub is 3.5 times the diameter and it is 248.5 mm. Then the length of the key is half of the length of the hub, it is 124.25. Then here we have to consider the square sunk key, so the width is same as the thickness and that is equal to d by 4. We don't need to take the standard key dimensions from the data book. So the width and thickness is equal to 17.75. Okay. So the third step is checking the strength of the coupling. mt is equal to pi by 16 tau 2 capital D power 4 minus small d power 4 divided by capital D. So substitute all the values. Here we are going to check the strength. So we have to calculate the value of tau 2. Don't substitute the value. So calculate the value of tau 2, that is 2.9 Newton per mm square. And in the problem we have assumed the tau 2 value as 15 Newton per mm square. So the calculated value is less than the allowable value. So the design is safe. So after designing the hub, the next one is design of key. Okay. So first consider the shear. Substitute mt. L is the length of the key, W is width, D is the diameter of the shaft. So the calculated tau 1 is 35.6 Newton per mm square and it is less than the allowable tau 1 value, that is, so that is 40 Newton per mm square. So the design is safe. Then considering crushing, the calculated sigma 1 value is 71.15 Newton per mm square, that is less than 90 Newton per mm square, that is the allowable value. So the design is safe. Now we have designed the shaft, hub and the keys. So we can move into the resulting dimension. So draw the muff coupling drawing and write the dimensions. So D is 71 mm, that is shaft diameter. Capital D is the diameter of the hub. L is length of the hub and small l is length of the key. W is the width of the key and T is the thickness of the key. Okay. So the procedure is almost very simple. Next, the tutorial problem is assume suitable design stress. Design a muff coupling to transmit 30 HP at 1440 RPM. So here the power value is given in HP. Okay. And we know that 1 HP is equal to 0.746 kilowatt. Remember that 1 HP is equal to 0.746 kilowatt. So 30 HP is 30 into 0.746 kilowatt. So you will get 22.38 and I'm going to convert the kilowatt into watt by multiplying 10 power 3 and the speed is given. Okay, so you can assume the material and you can design the muff coupling.